Hi, welcome back to Outsmartable Instructional Videos. Today we're talking about trigonometry. In particular, we're looking at fundamentals of right triangles. It's a little introduction. Let's start with some terminology. Definitions. Angles are acute if they are less than 90 degrees in measure. They're called obtuse angles if they're greater than 90 degrees in measure. A triangle that has all three angles less than 90 degrees, in other words, three acute angles, is called an acute triangle. A triangle that has one obtuse angle and two acute angles is called an obtuse triangle. And then finally, a triangle that has one right angle and two acute angles is referred to as a right triangle. And that's what we're going to be talking about today in particular. That's what trigonometry is all about, ratios of sides of right triangles. An isosceles triangle, a little more terminology, is a triangle that has two sides that are the same length. An equilateral triangle has three sides that are all the same length, as well as all three angles, equiangular. And you need to know that every triangle, if you add the three angles in a triangle together, you always get a sum of 180 degrees. Let's look at right triangles. That's what trigonometry is centered on. Some fundamentals of right triangles. Of course, it has a right angle and two obtuse angles. Here's what your right angle looks like in this triangle, and here it is in this one. The hypotenuse. You need to know that in a right triangle, the longest side is called the hypotenuse, typically abbreviated with an H. And then the other two sides are referred to as opposite side or adjacent side, referencing a particular angle of concern. So for example, if you're talking about angle A, then B is the adjacent side and A is the opposite side. If you're talking about angle D here, the opposite side is side D and the adjacent side is G. So you need to start with an angle of concern before you can identify the opposite and adjacent side. And know that the adjacent side for angle A is different from the adjacent side of angle B. So you have to start with this angle of concern, and then you can talk about the adjacent side or the opposite side, and the hypotenuse is always the longest side. Now, trigonometry is all about ratios. Ratios of sides of triangles. And what's really interesting about right triangles is that no matter how big or how small your triangle is, if this angle has the same measure as this angle, then the ratio of this side to this side is equal to the ratio of this side to this side, or the ratio of this side to the hypotenuse. It's the same in this triangle as long as these angles are the same. So no matter how big the triangle is, as long as the angles are of the same size, you get the same value for the ratio. Let's see if we can identify these six ratios, these six trigonometric functions. Here's a little mnemonic that is frequently used to help you memorize how to calculate these six trigonometric functions. The sine is equal to the opposite side divided by the hypotenuse. The cosine, that's another trig function, is equal to the adjacent side divided by the hypotenuse. And the tangent is equal to the opposite side divided by the adjacent side. Let's try it for a couple of these. What would, say, the sine of angle A be equal to? Well, the sine is the opposite side divided by the hypotenuse. How about the sine of angle G? What would that be equal to? Well, again, that's the opposite side, in this case it's G, divided by the hypotenuse, which is A. Now these letters represent a measure, of course. How about the tangent of G? What would that be equal to? The tangent is the opposite over the adjacent. So the opposite is G divided by the adjacent, which is D. The opposite over the adjacent. That's your tangent. How about the cosine? Cosine, let's try the cosine of, say, angle B. Cosine of B would be equal to the adjacent divided by the hypotenuse. Adjacent for B is A, divided by the hypotenuse. Okay, got the wrong marker here. You need to memorize some of these special triangles. You'll find them on the ACT test. Every ACT test kind of use these particular right triangles. One is an isosceles triangle where you have a right triangle and two 45-degree angles. And the lengths of the two sides forming the 90-degree angle have the equal length. 30-60 90-degree right triangle. You can see that the side opposite the 30-degree angle is 1/2 the length of the hypotenuse. And if you have an approximately 53-degree angle, this is a very popular right triangle because the sides are proportionally 3, 4, and 5. Let's see how this table is derived using the definitions of the trig functions for these special triangles. You need to be able to write this table out before sitting down to take that ACT test, or you need to be able to identify these values. How about the cosine of 45 degrees? Cosine of 45, here's 45, that's equal to the adjacent side, A, divided by the hypotenuse, which is the square root of 2A. A divided by the square root of 2A is equal to 1 over the square root of 2. Or if you rationalize that by multiplying top and bottom by square root of 2, square root of 2 divided by 2. How about the tangent of 60 degrees? Tangent of 60, that's the opposite side, radical 3 over the adjacent, which is A. Radical 3A divided by A would be radical 3. So you see how these values are derived using the definition of the 6 trigonometric functions. By the way, the cosecant is just the reciprocal of the sine, the secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. So if you know this little mnemonic and you know these reciprocals, you have the definition for all of these 6 trigonometric functions. But again, you need to memorize the values of the lengths of the sides for these special triangles and be able to generate this table, because you'll need those values on the ACT test. You need to also know this Pythagorean theorem that says the hypotenuse squared is equal to the sums of the squares of the other two sides. Here's a representation of a unit circle. Here's your origin right here. This is a positive x, positive y, negative y. In this first quadrant, any angle that you might have in this first quadrant is such that if you calculate this, any of the 6 trigonometric functions, they'll all have a positive value. An angle in the second quadrant is such that only the sine and the cosecant have positive values. And the third quadrant, any angle in the third quadrant, any angle whatsoever, has a tangent and cotangent which is positive, but it will have all the other 4 trig functions will be negative in value. And in the fourth quadrant, your cosine and secant have positive values, the other 4 are negative. You need to know that the reference, the starting point for these angles is your positive x-axis. Positive angles are measured going in a counterclockwise direction, and negative angles are measured going in a clockwise direction. Frequently the unit circle is used to represent your angles and their values, because the hypotenuse always has a value of 1. So your cosine would be x over 1. The cosine of 45 degrees is equal to 1 over the square root of 2. And the sine of 45 degrees is y over 1. Y would have to be equal to See the sine of 45, 1 over the square root of 2 also. So the coordinates of this point give you the cosine and the sine of the angle. No matter what angle you draw, the coordinates of the point on the circle always give you the cosine and sine, since the hypotenuse is equal to 1. We'll work with these ideas more, and we'll solve some problems in the succeeding videos to follow. These are the fundamentals. This is the starting point. This is what you need to know before we can work any trigonometric problems through. Okay, see you next video. Thanks.